Okay, so here's some more problems from section 9.4. Tony is 19 years older than his sister Kate. In 5 years, he will be twice as old as Kate. How old is each of them now? So we've got this problem that basically gives us the age difference between Tony and Kate. And if Tony's age and Kate's age are the x and the y that we've been kind of establishing in the past, we could kind of say that, if you took Tony's age and subtracted 19, you'd get Kate. That would be an equation of truth. You could also say Tony take away Kate in terms of age equals 19. So there's an equation that we can get out of that. And then it says in 5 years, he'll be twice as old as Kate. How old is each of them now? So the second equation will involve this information, and it looks like if we were to add 5 to their ages, it would be a doubling of Kate that would give us Tony. If Tony is twice as old as Kate at that point, to set up the equation, you're really going to multiply by 2 on Kate to make it match Tony. I think that makes sense. Going through the tutor mode, they're going to ask us what are the equations that we want to use. So the difference of 19 years, like I was saying, and they define it as x is Tony, y is Kate. I'd say x minus y equals 19. That makes sense, or x minus 19 equals y. It really is the same equation. The second one, Tony will be twice as old as Kate in 5 years. That one's a little bit weirder because if I take Tony, who's x, and I add 5 to his age, what we're suggesting is that it would take a doubling of the same thing for Kate in order to equal Tony. So I believe that the equation could actually be something like this. And I haven't gone through this to see if they like this or don't like this, so we'll find out. But that if you add 5 to Tony's age, it would be equal to doubling Kate's age increased by 5. So that's kind of what I get out of this. Okay, you would increase each by 5. It's a doubling. Let's see if they like that. Sometimes you never know. Alright, so they say that looks pretty good. Alright, so we kind of captured the essence of this problem. And with these two equations, I know that that bottom one looks a little bit weird, but it's only because of the parentheses, really. And if you were to distribute in the 2 and then move things around, you would really have an equation that's kind of like x take away 2y equals 5. Like if you did the math out, you'll see the x can stay there. Distribute the 2 in, you're going to get a 2y that you can subtract over, and then you could move potentially the 5 over and subtract it from 10. You'll have a 5 on the right hand side. So x minus 2y equals 5 would become the bottom equation. And then when you solve it down, I believe that you could do an addition method pretty quickly. And I think you're going to find that Kate's age is 14. And of course her brother is 19 years older than that. Because these are the current ages. You get 33. And then just kind of check and make sense. See if it makes sense that if I were to add 5 to each of those numbers, would I get a doubling? If I add 5 to 14, I get 19. If I add 5 to 33, I get 38. 38 is indeed twice as much as 19. So that problem makes sense. Okay. So, and also, again, make sure that you check your work as you go. Like I just kind of talked through. It's really a nice benefit to these types of problems that whatever you get as an answer, you can check back, either with the equations that you have, or just kind of even with the wording of the problem, like I did. And that should help you a lot with little mistakes that you'll catch them and have a little bit more success when you certify. Okay, so the next example, Michelle has some dimes and quarters. If she has 14 coins worth a total of $1.85, how many of each type of coin does she have? So dimes and quarters must be our x and our y. And to construct two equations, we can use the information that we've got for 14 coins and $1.85, and really what we know about dimes and quarters in terms of their worth. So I think we can go through the tutor mode like we have for the others, just so you can kind of see me fill in those boxes. And actually, that's good that they show D for dimes, Q for quarters, kind of breaking that pattern of X and Y so that we can get something a little bit more descriptive, and oftentimes that helps when you start making the equations. The first equation, if there's 14 coins, and D and Q are the number of dimes and quarters, I could really just add them up and get 14. So D plus Q equals 14 pretty quick. Second equation, a little bit more to it, but not much, in that it's 10 cents per dime. So 0.1 times D, and then plus 0.25 per quarter, and that should equal $1.85. So I believe these are our two equations that we can use. Okay, so Hawks likes that answer. And then from here you have to try to solve. You could either multiply everything in an equation or both equations by something that's going to use the addition method and cancel something out, or we could do a substitution method. So again, I'm not going to go through that process if you're unfamiliar with it. One, because it's hard to kind of communicate it on the computer here, and I've also made the effort in sections 9.2 and 9.3. But I'll work it out quickly on paper and let you know what I get. Okay, so what I did is I looked at these values here on the bottom equation. I noticed the 0.25, and I thought about if I multiplied 0.25 by 4, I get 1. So to be the opposite of 1Q up here, I multiplied by -4, and as a result, I ended up with negative 0.4D take away 1Q equals negative 7.4. And then combining the columns, I end up with 0.6D. These cancel, and I end up with 6.6. So if you divide 6 by 6 by 0.6 to get the D by itself, you end up with 11 for D. So the number of dimes is 11, and obviously plugging back in is pretty easy on this one, because if I plug in 11 for D, I'm going to get 3 for Q. So 11 dimes and 3 quarters. Okay, next problem. The difference between two numbers is 48. 6 times the smaller is equal to 7 more than the larger. What are the numbers? So this shouldn't be too bad. I am running a little bit low on time, so just briefly, just to give you something that will help you with that. The difference of the two numbers, if they're x and y, is 48. We get that there. And then 6 times the smaller. Okay, so if the smaller number is y, I could say 6 times the smaller is equal to 7 more than the larger. So these two equations should work for us. And it looks like it might be possible to do a substitution using either one. I'll work it out quickly and tell you what the answer should be. Okay, with just a few seconds left, I did the work. I found 59 for x, and 11 for y.